Hi everyone, my name is Stix and welcome to our daily Leetcode challenge, similar string groups. So we are giving two strings, x and y, and they are called similar if we can swap two letters in different positions of x so that it equals to y. Also, two strings x and y are similar if they are equal. So far so good. For example, we are giving two strings, tars and rats, and they are similar because we can swap positions 0 and 2 and transform them. Rats and arts are also similar, but star is not similar to tars, rats, or arts. Together, this forms two connected groups by similarity, and we do need to notice that tars and arts are in the same group, even though they are not similar, which means that I cannot transform by swapping two different positions, two letters in the string, and getting arts to tars and vice versa. But because I do have some intermediate string, which is rats, I can transform arts into rats and do the opposite way. And therefore, they are all in the same group. Star, on the other hand, cannot be achieved because we have more than two different letters. In this case, we have three. That is not compatible to any of those strings. We are giving a list of strings where every string in str is an anagram of every other string in strs. How many groups are there? Let's just say for an example, we got mtv, okay, and a similar string for it is gonna be, for an example, tmv. Notice that we do have two elements different, which is the first one and the second one. And we can also get VMT. On the other hand, we could not get, let's just say for an example, we can see that between those two strings, we also have some sort of similarity. But let's just say for an example, let's assume that I have this string. So we got T, V, and M. And in this case, both of these strings are not similar, but we do have this intermediate. So we can compensate for that and go through the letters and see that, okay, this is similar to this one and this is similar to this one. So eventually they're going to be under the same group. Now, our basic intuition is to go through all the letters and look for different groups of them. But we can look at each and every string as a node and basically form some sort of a connection between those strings. So let's just say if string 1 is similar to the other string, we can do that, and let's just say that this string is not similar to this one, but it's similar to this one. So we can also concatenate them into the same group and therefore say we have some similarities. However, let's just say for an example, I got, let's just say, a string that is similar to another string and another string that is similar to those strings, and then I got my fourth string, and none of the strings that I have in this group is similar to this one. I can say for sure that this string is not compatible. Okay, so let's start coding. strs.length, and I do want to create some sort of an adjacency list. Since we going to consider each and every string as a node, we want to see the connection between them. So I'm going to create some sort of hash map, and I'm gonna take the first element of the hash map is gonna be an integer, the second one is gonna be the list of integers that are similar, and we call this adjacency list, and it's a new hash map. Let me just take that away, and it's a new hash map. We're done. Now, what I want to do is basically iterate for every single string and see whether or not they are similar. Now, before I'm going to do that, I need to determine how I'm going to say that string is similar to another. So let me open a new function. It's going to be a private one. So let's just say we're going to take it as a boolean, and we're going to check is similar. And basically we are getting two strings, string A and string B. Now we want to check whether they are different or not. Different, I mean similar. So if they have either two different elements, characters are different, or they are the same, we can call it true, and otherwise we're going to call it false. So I'm going to make a diff element, which basically counts the number of characters that is different. And basically we know all of the strings are anagrams, so they are in the same length and we don't need to check them. So we're going to go through every single character. I'm going to take A length. It doesn't matter, we can take B as well. And it's a simple for loop. And if my first string, which is A, at the char I, is not the same as B, I can say diff plus plus. And once we go through all of the characters, we can say that we need to return true if diff is equal to 2 or diff is equal to 0. So this is going to cover the similarity we were asking for. And now I'm going to go back to my main function and I'm going to start iterate over all of my strings. So I'm going to go for and then it's going to be the size of n and I plus plus. Then I'm going to iterate for every single string that is left, but I do want to make sure that I'm not gonna do double checking. So I'm gonna say j is equal to I, j is less than n, and obviously increment j. Now I want to check if they are similar, so I'm gonna use my isSimilar function. So if is similar, and then I'm going to pass str s on the I spot, and the second argument is going to be the str s spot. So basically, sorry, on the j spot. And so basically now we are going to go through every single string, and if they are matching, that's where my adjacency list at the beginning of the video is coming up, and then we are going to edit. So we're going to use adjacency list, and we use a very convenient Java function which is called compute if absent, and if we already have this value it's going to edit. If we don't have it, it's going to create one. And so new array list, and then add I to it, take it over there, and we're going to do the same but reversed for I and j as well. It can either be this way or this way, it doesn't really matter. Now, once we build our adjacency list, we want to iterate through, we want to basically figure out which string belongs to which group. So I do not want to make any additional computation or any additional double checking, so I'm gonna create some Boolean array and we call it visit, because strings we already visited, we don't want to visit again. We know they belong to some sort of group, and it's going to be the size of n, which is basically all of our string size. And we're going to initiate count variable. Count is going to basically count how many groups, so we can call it count groups. And now we're going to iterate for the last time for every single string. And what we're going to do is quite simple. We're going to use a deep first search, and we're going to use it in order to find for which group belongs which string. So if I already visited this current string, if I didn't visit it, so I want to check it. So I'm gonna use DFS, and we're gonna build it right now after we do that. But since I don't have DFS yet, I want to do it before. Now, DFS, we're gonna go very simple, basically the main strategy. If I got a string and this string is working and it's similar, I'm going to look for another string and another string and another string, and if it's not, I'm going to return it. So deep down, we're going to use private void, it's DFS, and what I want to do is I want to know which node I got, basically which string. I'm going to consider it as node, so it's going to be an int. And then I want to pass my adjacency list, so I can continue searching for any other strings that are similar. And oops, forget that. And maybe I'm forgetting something. Oh, I just forgot the name. So it's called adjacency list. It's gonna be small, and obviously I want the Boolean array that I already made, which is visited or visit. Now, once we got into our DFS, which is the depth first search, first of all, we want to make sure that we visited the node that we want, to make sure we're gonna not visit it again once we check it over here. And the second thing that we are going to do is see whether or not we already have some sort of neighbors in the adjacency list. So we're gonna take the adjacency list and check whether this contains any key in some sort of node. So if it has no keys at all, we're gonna basically just return it. So this is our edge case. Now, when it really comes alive is we are looking for neighbors. And our neighbors is gonna be from the adjacency list. So we're gonna take the adjacency list and get all of the nodes, all of the strings from the same node, basically all the values matching to the key, which is node. And then we're going to check again. If we already visited neighbor, then, sorry, if we didn't visit it, which means that we want to visit him now, we're going to set visit neighbor to true. Oops. And then we're going to say, we're going through DFS again, and we're going to pass our neighbor, and we're going to pass our adjacency list, and we're going to pass our visit Boolean array. And once we get back to our main function, we're going to do the same. So what we want to do is we want to pass our current string. Okay, so our current string is represented by an I because for every single string there is a matching integer. So we're gonna pass I. We're gonna pass that adjacency list. And then we're gonna pass the visit array. Now, the trick is basically if now we know that there is a new, how can I tell if there is a new group? I can tell if there is a new group by saying, okay, every time that I'm gonna create a new DFS search, so I am currently at this first node, so I'm looking and then I'm gonna interact with this node and I'm gonna interact with this node, so I'm basically visiting all of them. Now let's just say I stop here and now I'm going to get to another one and I want to start looking from there. So I'm checking this one out and I'm looking for another strings that match. Now every time I'm going to start a new search, I'm basically creating a new group of elements that are similar in some sort of way, because once I'm finished searching in this one, I know that the rest of the strings that is going to be in the array are not similar, so I'm creating a new group. So basically it means that every time I'm gonna go into this if block, I'm gonna raise count by 1 and count groups, sorry. And eventually, once I'm finished doing all of that, I'm going to return count groups. Now notice that we can do this. This is a recursive approach of DFS. This approach can be also implemented using stack for DFS. We can also implement it using stack and BFS. We can also do it BFS recursively. But main idea behind it is that every time I'm looking for a new group, there is going to be an increment in the count, because once I'm finished with DFS, I know that it's been through all of the strings that are matching. Now let's just give it a go. We see that we got our cases right. And if we press submit, we got it. It's not quite efficient because obviously we are using recursive approach, but if you got any questions, I can also bring up the iterative approach. Thank you for watching and have a great day.